All right, if it got cut off, basically, we're going to compare the total number of solutions, which always matches your degree. So degree 3 has 3 solutions. A degree 9 polynomial would have 9 solutions. And in order to see if they're real or imaginary, you're going to want to graph it. And if you can actually see where it's crossing the x-axis, those are your real solutions. So in our last example, we saw that there were 4 solutions, but we could only tell on the graph it was crossing twice. So that means it had 2 real and 2 imaginary. Now there are some times where it gets a little tricky, and that's why we're going to work the next 3 together. Okay? So let's take a look, and it says that we're going to use the zero product property. Now the difference between this and last chapter is last chapter everything had degree 2. They were quadratic. But this time we're going to work with higher degree polynomials. So the first thing I want you to get in the habit of doing is number 11. Right away we know that this is degree 3. So right away we can say that this is going to have 3 solutions. But I think it's important to take out your calculator. I know it's kind of hard to see sometimes on here, but if you take out your calculator and we actually graph 2x to the third minus 12x squared plus 18x, and you might need to change your window. You might not be able to see this. But what happens is, I'm going to zoom in just a little bit. And it looks like it comes up and crosses. Ooh, but it looks like it's not really crossing twice. It looks like it's hitting it once. So what's interesting is this looks like it only has 2 because it goes back up forever. So what really you do is if you pair this knowledge with the actual solving, it should hopefully make sense. So I'm going to zoom back out, and we'll come back to this graph and take a look at what we get. So the number one way that we're going to start solving is by factoring. So the first thing we're going to look for is a GCF, that greatest common factor, and sure enough, I hope you see that the greatest common factor is a 2x. So when you factor out a 2x from each term, you are left with x squared minus 6x plus 9. Now, you always want to keep checking to see if you can factor more. Well, we have a trinomial. We love that the leading coefficient's 1. So we're looking for 2 numbers that give us a product of 9 and a sum of negative 6. Well, that would be negative 3 and negative 3. So that trinomial then factors into x minus 3 times x minus 3. Now, we have done our job. Everything is factored. So now we can use that zero product property. Well, 2 can't equal 0, so we could easily divide both sides by 2 and get rid of it. So this whole left side will be 0 when x is equal to 0. When will x minus 3 equal 0? Well, that would happen if x were 3. And when will this equal 0? When x is also another 3. Uh-oh. So this happened earlier in our notes, but what happens is I'm not going to mark it wrong if you leave it that way. But what I tend to do is I tend to kind of remind students that we have 3 solutions. And people are like, well, wait a minute, this is only 2. Well, what happens is this is a repeated solution. So that real solution. So all 3 solutions, 0, 3, and 3, are real. And I know you're thinking, well, what about on the graph? Well, on the graph, what happens is this is 0, x equals 0. This is 3. It's not going to hit again, but to use the theorem, there's 3 solutions. So that's why when you see your factors, you get 0, 3, and 3. I'm just here to remind you, hey, you do have 3, but one of them is repeated. And it's really hard to see that on the graph. That's why we really need to do the algebra and the graph together, okay? All right, let's go on to number 12. So once again, we know that we're going to have 4 solutions. And the first thing I would tell you to do, once again, is let's see what this looks like when we graph it. So we're going to graph 4x to the 4th minus 40x squared plus 36. And when you graph it, it seems to look like this W. So I can see 1, 2, 3, 4 times that it's crossing the x-axis, which means all 4 solutions are going to be real numbers. So now you kind of know what to expect as we solve, okay? So now let's solve this. We're going to always look for a GCF first. So I'm going to factor out a 4. I think that's all we can do. So I'm left with x to the 4th minus 10x to the 2nd plus 9. Now once again, we're left with a trinomial where the leading coefficient's 1. So we're looking for 2 numbers that give us a product of 9 and a sum of negative 10. Well, that's going to be a negative 9 and a negative 1. Now the only slight thing, and we saw this in our factoring assignment from last night, is that normally we would put x a minus 9 and a minus 1, doesn't matter the order, but this is an x to the 4th, and the middle term is x squared. So when you would FOIL this, we'd have to get back to where we started. So that is what you should get when you factor. Now, you have to ask yourself again, can we factor more? Well, in this case, we actually can, because this is a difference of squares, and this is a difference of squares. So, this factors into x plus 3, x minus 3. This factors into x plus 1 and x minus 1. So we literally have 4 times 1, 2, 3. So we have 5 factors, but remember, 4 can't be equal to 0. So that's never going to change, but we can ask ourselves, when will these other factors equal 0? So that will happen when x equals negative 3, if this were a 3, if this were a negative 1, and a positive 1. And sure enough, we have 4 real answers. Okay? All right, the last one should get you through enough, and I will do the bottom 2 if we need to, but this should get you enough to be able to do your assignment. So in this problem, once again, let's start by graphing. We already know to expect 3 solutions. So I'm going to graph x to the 3rd minus 1. Oops, that is not x to the 3rd minus 1. Let me try this again. X to the 3rd. Oh, there we go. Minus 1 has to be off to the side. Okay. So what happens is, oh, let's look. We can see, and I'm going to zoom in, that it comes up and it appears that it's only crossing the x-axis one spot that we can actually see. But we know there's 3 solutions, so this means 2 things. Either this solution right here gets repeated 3 times, like number 11, or it has 1 real solution and 2 imaginary. So the way that we have to determine that is we have to solve it. So remember, we're starting all of these by factoring. And there is no GCF, so a lot of people want to give up. But remember, this is a difference. This is a difference of cubes. The cube root of x to the 3rd is x, the cube root of 1 is 1, and we can use that SOAP acronym and that formula. And remember, we're going to have 3 solutions. So if I factor this into that SOAP, it's same sign, opposite, always positive. So I would have x squared and then 3 at, where am I getting 3 from? Sorry y'all, that should be a 1. So the cube root of x to the 3rd is x, the cube root of 1 is 1. So that's just 1x, and then we have a 1. So we've factored everything that we can. Now, if you notice, we're set up to use the zero product property. So if you multiply this times this to get 0, this one right here, that will happen when x equals 1. So we already have one real solution. Now the tricky part is we now have to figure out, well, when will this whole thing equal 0? And in order to do that, we're going to have to think, wait a minute, does this factor more? Well, is there anything that multiplies together to give you 1 and adds to give you 1? Well, 1 times 1 is 1, but 1 plus 1 is 2. So it doesn't factor. So that's where last chapter we learned multiple ways to solve a quadratic. So my best bet would probably be to use the quadratic formula, and that's what we did on the front. So we're going to solve this trinomial by doing negative b plus or minus the square root of b squared, which I'm going to go ahead and fill in, 1 squared minus 4 times a times c all over 2 times a. Now lucky for us, in this trinomial, the a is 1, the b is 1, and the c, the constant's 1. So now we work on this quadratic formula. So we have negative 1 plus or minus 1 squared minus 4 all over 2. And that gives us negative 1 plus or minus the square root of negative 3 all over 2. Now all we have to do is write this correctly. Remember, a negative underneath the radical means that it's going to be imaginary. So our one real answer is 1, and we could actually see that. Remember, we could actually see that on our graph. So there's 1, but the other 2 are imaginary. So we're going to write this as negative 1 plus or minus. The square root of negative 3, remember, would be written as I. Square root of negative 1 is I. Radical 3 all over 2. And there are 3 answers. You have one real one, and you have negative 1 plus I radical 3 over 2, and negative 1 minus I radical 3 over 2, and those are both imaginary. Okay? Now, that's really where I'm going to stop. That should be enough information. If you do need to try these bottom 2, if you feel like you need a little bit more, really the only difference is you're finding the x-intercept, so you have to plug in the 0 for y, but you're going to start these by factoring also, okay? So you definitely want to factor first and see what happens, and you want to graph them. So we know to expect 3 solutions, and we know here to expect 4. The question is are they real or imaginary? So I'm going to give you these answers that if you do need to come in and see me, these 3 answers are all real. 0, 4, and negative 3/5. Out of these 4 solutions, 2 are imaginary, a plus I radical 6 and a minus I radical 6. And then you have a positive radical 3 and a negative radical 3. So you have 4 answers. 1, 2, 3, 4. Okay? All right, if you cannot get these, see me during XH. If you need them, if not, go to your assignment. Thank you. Bye.